Okay, now we're going to look at benzynes. Benzynes are these crazy, weird intermediates. This kind of looks like a SNAR reaction when you are looking at it, because we have what looks like a nucleophile, and we have our benzene ring with a chlorine attached. But notice there are no strongly electron withdrawing groups. And so this reaction is going to have to go through a different mechanism than our nucleophilic aromatic substitution did. In benzyne chemistry, we form the benzyne intermediate instead of doing the SNAR. And this will only happen when we don't have strongly electron withdrawing groups at the ortho and para positions. We also need an incredibly strong base. So you'll notice in this top reaction, right, we have a very strong base. In the bottom reaction, we have sodium hydroxide, and that's not a super strong base, but we do have a very high temperature. So that's how this bottom example is going to occur. So what happens in benzynes? Let's look at the mechanism. In this case, we can see that the very strong base is deprotonating our benzene ring. This negative charge then comes down and kicks out a chlorine, and we have this highly unstable benzyne intermediate. So this is the benzyne intermediate right here. It's got a triple bond in a benzene ring, which you can imagine is very, very unstable. This is highly strained, and that makes it extremely reactive. The benzyne can then react with another equivalent of NH2-. And that's what you're seeing in the bottom here. NH2- comes in, and it can attack either side of the benzyne. So it can attack the left carbon of the benzyne or the right carbon of the benzyne, as shown in the bottom. When we get attack at the left carbon of the benzyne, the electrons are pushed onto the right carbon. And when we get attack at the right carbon, the electrons are pushed onto the left carbon. The resulting intermediate has a negative charge in the benzene ring. The negative charge then picks up a hydrogen from ammonia. So this is just a proton transfer step to form our product. In the bottom example, notice that what happened was because of the location of the negative charge, we get a different product. So the benzyne can be attacked on either side, and that could potentially give us multiple products. Let's look at some more examples with benzyne reactions. In this particular reaction, we're labeling this carbon here. And our strong base is going to form a benzyne, and you have two possible products. So it is going to pull off the hydrogen, I'll draw on the hydrogen here, next to our leaving group. And that negative charge can come down to form the benzyne. To get to the top product, our nucleophile NH2- would have to attack at the starred carbon, or the nucleophile can attack on the right carbon to get the right product. In this next example, you can see that the benzyne can form between these two carbons here. In fact, I'll label them as carbons 1 and 2. And then the NH2- can attack either carbon 1 to give us the first product, or carbon 2 to give us the second product. In this last example, you can see that the benzyne can be formed. It can also do different types of reactions. This bottom reaction here is a Diels-Alder reaction, which we're going to cover in chapter 24. So this is just another cool application of benzynes. So that wraps up benzyne reactions. This is the end of chapter 23. You're going to want to review the study guide and do the clicker questions for the chapter.